Okay, so what we're trying to do here is we're trying to find the volume of this pentagonal-based pyramid. How do you find the volume of a pyramid? Okay, so we need to find the area of the base, multiply it by the height of the pyramid, and then divide it by 3. So the first thing we need to find is the area of the base. And what's the shape of this base? Right, it's a pentagon. How are we going to find the area of this pentagon? Given these dimensions, how do we find the area of the base? Okay, so we're gonna find the area of the base, which is this, and we know that the base can be broken up into 5 triangles. So we're gonna find the area of one triangle. How do you find the area of a triangle? Yep. Base times height divided by 2, and do we have the base of the triangle? What is it? 5.8 times the height of the triangle divided by 2, and that will give us the area of one of the triangles in this pentagon. Okay, so when we calculate it, we can find the area of one of the triangles is 11.6 centimeters squared, and how many triangles are in this pentagon? 5, so we're going to multiply 11.6 times 5. Good, 58 meters squared, and what does that represent? The area of the base, which is what we needed to find, right? We needed to find the area of the base. Okay, so now that we know the area of the base, we're going to plug in the value of the height. And we're told in this question that the height is 8.1 centimeters. And that represents the height of the pyramid, not of the triangular face, not of the base, but of the entire pyramid. So we're going to multiply the area of the base times the height and divide it by 3. Okay, so when we multiply 58 times 8.1 and divide it by 3, we get 156.6 centimeters cubed, and that represents the volume. Okay, so now we know how much space is occupied inside this oil lamp, and we're told that this person is buying oil in a bottle, and it's 750 milliliters. So 750 milliliters of oil comes in a bottle, and we want to know how many times can we fill this oil lamp with this bottle. Okay, so because we have the unit of centimeters cubed, well, we know that 1 centimeter cubed equals 1 milliliter, which means 156.6 centimeters cubed is equal to what? 156.6 milliliters. So to figure out how many times we can fill this up, we're going to divide 156.6, and what do you get? Okay, our answer is 4.8. So if we had 750 milliliters of oil, how many times could you fill up the bottle completely? Okay. So you can only fill the bottle 4 times. You don't have enough to fill it 5 times, and that's the answer. Okay, so in this question, we're given the dimensions for a cone and for the cylinder, and we want to know how many times do you need to fill the cone, so the paper cup, in order to pour it into this cylinder in order to fill it up. So we want to know how many times do we have to fill up the cone, pour it into the cylinder, and fill it up completely. What are we going to find here? We need to find the volume of the cone, and we need to find the volume of the cylinder. So let's start by doing that. The formula is pi r squared times the height divided by 3. Do we know r for the cone? Yeah. Good. 4 centimeters. And do we know the height of the cone? Yeah. No. 10 centimeters for the cone. So let's plug in the values. And which part of this equation are we going to solve first? Using BEDMAS, which part of the equation are you going to solve first? The exponents. So 4 squared is what you want to do first. So we have pi times 4 times 4, 16 times 10 divided by 3, and simplify to get the volume of the cone. Okay, so when we calculate it, we find the volume of the cone is 167.6 centimeters cubed. Now we need to find the volume of the cylinder. Okay, so we're going to do that on the next page. Find the formula for volume of a cylinder. What's volume of a cylinder equal to? Okay, so volume of a cylinder is pi times radius squared times the height. Were we given the radius of the cylinder? What was it? 4 centimeters. And were we given the height of the cylinder? 20 centimeters. So we're going to plug in those values again, and using BEDMAS, which part of the equation are you going to do first? Exponents. So 4 times 4? 3.14 times 16 times 20. What do you get? Okay, so when we calculate it, we find the volume of the cylinder is 1,004.8 centimeters cubed. What was this question asking us to find? Okay, now that we found both volumes, we want to know how many times can this cone, if we fill up the cone, how many times can it be poured into the cylinder? So what are we going to do with these two values? Divide them. Good. So we're going to divide 1,004.8 divided by 167.6. Okay, so 5.99. So how many times can we fill this cylinder up? Approximately 5, almost 6. Because we used 3.14 instead of pi, it rounded down a bit to 5.99, so we could fill it approximately 5 times, almost 6 times. And that's it.